We have product to sum identities that are obtained from the sum and difference properties. So here are the four that we have. We're looking at the products of sine and cosine functions. And notice that all of them involve the sine and cosine sum and difference identities. So a couple of things to help kind of remember which goes with which. Note that the products of two cosines and the products of two sines, those use the cosine identities. And the ones that are product of a sine and a cosine are the sine product sum and difference identities. Now, actually, there's something kind of nice here. This first one, sine alpha times cosine beta, and the second one, cosine alpha sine beta, they're actually the exact same identity. Because if you just reverse the order that these are multiplied, you have sine of an angle times cosine of an angle. So really, you don't have to remember one of these. So I'd recommend not remembering this second one because it's got a negative in there, and sometimes negatives are maybe a little bit harder to remember. So I'd recommend just remembering this first one and then these last two here. So these are the product to sum identities. I'm going to go ahead and just prove one of these for you so that you can see how it works. And to do that, I'm going to look at just this first one, and I'm going to look at the more complicated side. So we're going to start with 1/2 times the sine of alpha plus beta plus the sine of alpha minus beta. And then we're just going to simplify this and hope that we get sine of alpha times cosine of beta. And this is going to happen by simply using the sum and difference identities for sine. So the sum identity for sine of alpha plus beta is the sine of alpha times the cosine of beta, and then plus the sine of beta times the cosine of alpha. So that's this first one here. And then we have plus, and then here we have a difference of the angles. So we'll use the sine difference identity. So this is sine of alpha times the cosine of beta, and then minus sine of alpha cosine of beta. And now we can just simplify. And notice that here the sine of, oh, I'm sorry, I messed that one up right there, sorry. This is sine of beta, sine of beta, cosine of alpha. Okay, that right there is the sine of alpha minus beta. And this right here is the sine of alpha plus beta. And now notice that this term here, sine beta cosine alpha, cancels out. So now we have, those are gone there. And these two terms combine, they're the same thing. So we combine those, and that combines to 2 sine alpha cosine beta. And now the 1/2 and the 2 cancel each other out, and we're simply left with sine of alpha cosine of beta. And that's the verification of that first identity. Okay, so these other ones are proven in the exact same way. You use the sum and difference identities, and everything just kind of works out nicely to be these things here. So what's really nice about these is actually if you don't remember what the identity is, you can kind of come up with them on your own if you just start adding and subtracting the sine and cosine sum and difference identities. In fact, that's what I do. I don't actually have these identities memorized. I just come up with them when I need them by thinking about what I might be able to do to get this the term that I'm looking for. So those are the three that you really need, and this, of course, the second one is this pretty much this exact same first one, just flipping around the angles.